This is the problems of some Hall effect. I have added some problems since there was no time. I am describing this as a separate section. Okay. So the first question we can look, it is as per Hall effect, if any specimen, so you the right side I mentioned a specimen for a sample case, you can consider other case also. There is no problem. Please mention that it is an induced electric field, not the electric field we applied. Okay. So the current we applied in this x direction. So in the electric field we are applying also will be in this direction and is placed in a transverse magnetic field. Then an electric field E is induced in the specimen. You can see that electric current is in this direction, magnetic field in this direction. That too we are applying. Then what is happening there? Electric field will be induced as a result of these two forces acting together. There will be an electric field will be induced. How would that be? Here you can see an electron here. Electron will be moving down. Then positive particles, positive charge will be appearing on the top as a charge separation. So electric field will be on this downward direction. E induced. So which option is correct? So this E induced is both perpendicular to B and I. D option is correct. Next question is, in hold voltage, which of the following is true? We can say that magnetic field is applied. I already told that current and magnetic field we are supplying. As a result, induced electric field is getting. Okay, is applied. What about electric field induced? That is getting. Electric field is induced. Don't get confused with that electric field induced. Okay. So this electric field we are applying. This is the effect of this current only. These two are we are applying this and this. Okay, these are same, but this is the result of that two force we are applying or two magnetic field and current. As a result, an electric field is induced. Okay. So I hope this everyone clear. Magnetic field and no, magnetic field is not at all induced. So first option wrong. Magnetic field is induced. Electric field is applied. No, they are talking about electric field induced. Okay, not about that electric field. So magnetic field is applied, is induced. No, magnetic field is applied and electric field is induced. C option is correct. One Hall voltage has same polarities for N type and B type. No, we told that for N type, whatever that N means negative, right? So Hall voltage will be negative. P means positive, right? So Hall voltage will be positive. If you have any doubt, means you please go through that lecture. Then next question, third question is this majority charge carriers in an N type have an average drift velocity V. The direction. The electric field is induced due to Hall effect acts in which direction? They are asking. So in this you can look this sample. Actually, electron will gain this direction velocity. I will rub this all. Okay. You please look that. Whenever electron is there, it will having a velocity in opposite to the direction of the current. Velocity will be in this direction. And magnetic field is in this direction. Okay, so V cross B will be which direction? V cross B in upward direction. So what they asked what electric field induced due to the Hall effect acts in which direction? So it will be no doubt it will be in B cross B direction. Yeah, right? Yes. You can see that it is B cross B in upward direction, but B cross B will be in downward direction. So you can say which option B cross B is the answer. Yeah. And third, I directly derived this equation RH is equal to mobility by sigma, or you can say mobility is equal to RH sigma, mobility into RH. So this option is correct. Next is this equation. So this question, okay, I think for yeah. They are asked to find the Hall voltage we want to find. So Hall voltage equation is nothing but IB divided by NET. You can see that I in the x direction, B in the z direction, and the whole voltage is as shown here. We are having B is there. So in this equation, B is there. E we already know the value. N is there because it is an N-type semiconductor. So we can assume that complete ionization, and we can treat N as the doping, same the doping concentration N also. So N is also given and T is given. Of course, it will be what T means, it will be the width, right? Yeah, it will be the width. I think, yeah, it will be the width. So T means T equal to width here. So it is already given. Then what are the details we don't having? We are not having the current. So what is the current equation? A into V drift into En. Or we can say we are given the mobility, right? So mobility is nothing but what the mobility equation? Mobility is drift velocity by E. So instead of drift velocity, we are going to substitute here and A into N mu N E. So this is the current. So from this equation you can find the current. Just plug in that value of the current in here. So VH equal to A into En mu N E into times B, this one. You can see here this one. Okay. Then Ne divided by T. Okay. So T is nothing but width here. So width will be cancelled, and here area is nothing but dy into width. Width will be cancelled and dy mu n EB. What is dy here? Dy is nothing but 4 into 10 raised to minus 3. It is meter. Okay. And mu times, okay, mu times n what? 0.38. And the electric field 700, but B is nothing but 0.5. And it will be, as you calculate, you can see that it will be 532 millivolt. You can check, okay, 0.38 into 7 into 0.5. It will be 532 millivolt. You can work out that. So I hope you understood. So this equation, this question answer is 532 millivolt, whole voltage. And the next question is this is a forward question, straightforward question. Okay. Sample of silicon is doped with this dope. So we know that intrinsic concentration is 5 into 10 raised to 10. So compared to this, is it a higher value? So we can assume that complete ionization, and we can say total negative carrier concentration is 10 power 70. Okay, complete ionization we assumed. And it is given that we are asked to find the whole voltage. Whole voltage equation is IB divided by NET. Okay, net. And I is given. What is the guy? Magnetic field strength. I is 1 milliampere. So magnetic field strength is minus 5. So please treat it is given in the Weber. No problem. Or you please assume that it is given in the test. Or just convert that. Okay. I think there won't be any problem. In this question, we can treat Weber as, or just convert to Tesla. Weber to Tesla. Okay. Okay. So I will be straightly substituting 10 raised to 5 minus 5. Then N is nothing but 10 raised to 17. E is 1.6 into 10 power minus 19. T is nothing but 100 micrometer. Sorry. Micrometer. So you can do this. I think there is a question mistake is there. Weber, it is not Weber. I think it is Tesla. Okay. So let me substitute this. Okay. So 10 power minus, this is 10 power minus 8, and this is 10 power minus 2. Is there any other factor? This is 10 power minus 4 into 1.6. I'll be cancelling this, and 10 power minus 2, 1.6. Uh, Let me check that. 10 power minus 2 divided by 1.6. Yeah, I think there is, it is not, it is Weber itself, okay. Weber itself. So Weber, we should multiply by minus 4. Here also minus 4. So 6.25 into 10 to the power minus 7, or we can say 62, no, sorry, 0.625 into 10 power minus 6. So this is the answer for this, 0.625. You can check, okay. I am doing this calculation so fast. You can check and confirm. This is the equation we are doing. You can confirm the equation. So the next question is Hall coefficient of a specimen of doped is, Hall coefficient is given. RH is given. So please think, I forgot that Hall coefficient is generally means unit is meter cube by Na. Hall coefficient is 1 by Na. So it is the unit is generally it is seen as m cube by c, not as SI unit, CGS unit centimeter cube by c. It is generally seen as m cube by c. Please remember that, okay. Then Hall coefficient has also this equation is there, and this equation is there, and this equation is there. Three equations are there. So in this case, resistivity is given. Resistivity is nothing but the reciprocal of conductivity. We are asked to find the mobility. RH is also given. RH is nothing but rho into mu. Mu is nothing but RH by rho. You can easily find out this question answer also. So these are some problems related to Hall coefficient. As there is no time in the first section, I am doing this as a separate section. So if there is any doubt, you can DM me. Thank you.